Hi, welcome to this briefing webinar about the accuracy of consensus real estate forecasts. My name is Ilir Nase, and I will be presenting recent research that we have done with Pat McAllister on this topic. The aim of this research is to evaluate the performance of the IPF 1 year ahead forecasts for rental growth, capital growth, total returns, and the implied equivalent yields. I will get back to the implied part of the equivalent yields in the following slides very shortly. The main contribution is threefold. The current study presents a longer study period and a broader sample across a range of sectors, using a wider range of performance measures. This is the first empirical work on the performance of consensus yield forecasts in the UK, and it also represents the first empirical work on the ability of UK consensus forecasts to predict relative performance. We want to describe a little bit better the hidden part of the yield forecasting. If we say that the expected capital growth can be estimated via expected rental growth and a yield shift impact, then we say that the expected yield shift is a function of capital growth impact and rental growth impact, which is more formally represented by the formula on the screen, where we have the delta y at period t+1, representing the 1 period ahead implied yield shift in percentage terms, and the delta rent representing the 1 period ahead forecast for forecasted rate of rental growth, and the delta capital representing the same for capital growth. If we were to illustrate this with an example, where we're considering here to have a yield at the current time of 5%, which we represent with y subscript t, and if we would have forecasts for capital growth of 10% and rental growth of 2.5%, then we estimate the 1 period ahead implied relative yield shift given by the formula in the previous slide as 7.32%. Then the 1 period ahead implied equivalent yield, so y at period t+1, is then 5% times this 1.0732, which is equal to 5.73%, representing a yield shift forecast in absolute terms of 0.37%. All else equal, this would result in a fall in value of 6.8%. Considering that historically other factors that impact capital growth, such as vacancy rates, have been reported to have a minor impact. Our work builds upon related research, which is particularly threefold. Is research that is exactly working on the IPF consensus forecasts, is research that has worked on forecasts that particularly has used models, and is previous research at an international level, particularly in the United States and Australia. What the previous research using IPF data is distinguished is that it has a relatively short period of time, and it does not use the wide variety of property sectors that the current research uses. Particularly the works of the most recent work of Papastamas and others stops at around year 2011, while our work considers a wider time period. So the data in this case is represented by two data sets: the IPF consensus forecast for the period 2005-2017, and we are using the February forecast, which represents roughly the 1 year ahead period, We also use the IPD MSCI reference tables that represent the actual observations for 4 variables of interest, namely rental value growth, capital value growth, total returns, and equivalent yield shifts. We know that particularly the UK audience would be familiar with these databases. However, while publishing the paper, we had a reviewer which was obviously not from a UK audience and had some difficulties in understanding the data. So that's why we are describing the data in a little bit more detail in here. So this is the wide variety of the sectors used in the most recent IPF databases and the typical variables of rental value growth, capital value growth, total return, which we additionally complement with the implied yield yield shifts that are estimated with a formula described earlier. And this is the graphs for the actual equivalent yields from the MSCI data. The graph on top shows the equivalent yield series, and the graph on the bottom shows the equivalent yield shift series in percentage points. Talking about the metrics that we use in our research, these are these are represented by a variety of well-established forecast performance measures and can be divided roughly in 2 groups, which is absolute measures, namely mean error, mean absolute error, and root mean squared error, and relative measures. The first of the relative measures is TIL's U2 statistic. It measures performance versus a naive forecast, so same as last year forecast. And it does so basically by comparing the root mean square errors. In terms of how to interpret the statistics, a U2 statistics of 1 means that the naive forecast method is as good as the forecasting technique being evaluated. If the value is smaller than 1, then the forecasting technique performs better than the naive prediction. And if the value is larger than 1, then the forecasting technique performs worse than the naive assumptions. And what we do in our current study, we estimate 1 year ahead forecast with MSCI actual data using simple trend models. I will describe them in a little bit more detail shortly. And then what we do, we compare the absolute performance measures to the consensus forecast, and then we also compare these models to the IPF's consensus forecast via the TIL's U2 statistic. Then what we do is we also estimate relative forecasting performance of the various sectors based on ranking. For the purpose, we use Kendall's coefficient of concordance, which is denoted by W, and takes a value of 0.1. It uses the correlations of the ranks of the forecasts and the actual data. And in terms of interpretation, to interpret this coefficient, a value of 1 indicates perfect ranking concordance of the forecast with the actual. So, talking briefly about the time series models, we use, in order to identify them, we use standard tests for the 32 series that we have. So basically, we have 8 probability sectors and 4 variables. We use autocorrelation coefficient functions and partial autocorrelation coefficient function graphs. We use this for 3 points in time. We don't use this for all the 13-year period that we have under investigation. We also do augmented decay Fuller tests and heteroscedasticity tests for the purpose. After these tests, what we see is there is no major stationarity or unit root issues with the series. As seen in slide 9, the equivalent yield shift series is stationary, although the equivalent yield itself is not stationary but shows a downward trend. After performing our tests, we find that the predominant model structure across the series is a second-order autoregressive model, and once we estimate our best fitted models, we observe that there is no major heteroscedasticity issues with our models. When we go to results, we start with absolute performance by comparing mean error, mean absolute error, and root mean square error. And the big takeaways from this table is that overall we see a systematic pessimism in the consensus forecast, as can be seen by the negative mean error values. We do not present here our simple trend models, autoregressive models. However, they performed particularly poorly in the retail sector. Like a more detailed table, including these models, can be found in the paper that we have recently with this research. What we also particularly see is that forecasting uncertainty may be concentrated in certain periods, as is shown in the following graphs, and particularly these periods correspond to the global financial crisis of 2008. And what is really important to observe is that the forecasters were particularly pessimistic about the rate of recovery following the crisis in 2009. When we go to the results related to the relative performance based on Kendall's coefficient of concordance, Kendall's W, we see a similar story again, that mostly concordance about the yields is at the lowest. And what can be seen immediately from the two graphs shown on the screen is that the consensus forecasts outperform the simple trend models. So if we were to summarize this, we would say that the consensus forecasts display a high degree of reliability in forecasting the relative performance of the various sectors, and the simple trend models or conditional mean models forecasts tend to perform much more poorly in terms of predicting the relative performance. And as we said, from the graphs, the consensus forecasts for equivalent yield shift were the least reliable. Now, when we move on to a relative performance related to the field's U2 statistic, and we described the interpretation of the statistics earlier, and now we focus also in identifying the source of the forecast from this statistics. It is divided into three, into bias, variance, and covariance. Bias basically represents systematic error. Variance represents failure to reproduce the actual volatility, and covariance represents unsystematic forecasting error, which is basically failure to predict unanticipated shocks. Related to the quality of a forecast, what is basically desired is that most of the forecast error should be in the covariance proportion, so the inability or the failure to predict unanticipated shocks. Basically, the table on the screen presents the outcomes of the consensus forecasts for U2 statistics and the error source for the four variables in consideration and the 8 property sectors. What are the big takeaways from this table is that overall consensus forecast outperform forecast with simple trend models. Again, we don't show this, but more detailed tables are available from the paper. We see that consensus rental growth forecasts tend to display the best performance with details U statistics being in the region of 0.5. Equivalent yield shift consensus forecast barely outperformed the naive assumption, as indicated by the values of the U2 statistics being in the region of 0.9, so almost 1, and in one case exceeding 1, so not being able to outperform the naive assumption. One important thing that we see is that the error source in consensus forecast is dominated by systematic forecasting error, which we consider to be the least bad error source. And for the simple trend models, the dominant source of forecast error was particularly the inability to model the variance of the time series, and this is something inherent to the structure. When we come to talk about conclusions, we see like the big takeaways from this research. We see that consensus forecasts exhibit a systematic pessimism in rent and capital growth predictions. We also see that poor yield predictions are the dominant source of forecasting error in capital and total returns. Again, poor forecasting performance is concentrated in periods affected by major shocks, which is again a recurring theme here that across the different tests that we have done. We also see that consensus forecasts show a strong record in predicting relative performance. We see that the results indicate variable performance compared to naive forecasts across the different variables, with rents with rents showing the best performance. We also see mixed findings with regard to forecast smoothing. Overall, we see that consensus forecasts perform much better than the simple trend models, the autoregressive models of second order. And what we see with our analysis is that the main source of error is due to unanticipated shocks, which is generally dubbed to be the least bad error source. Now, some further reading and contacts. A full paper can be downloaded from this link, and further contacts of the authors are also given there. In the paper, there is also some supplemental material related to the tests that we did, particularly for the simple trend models. Thank you very much for your attention.